I'm Gayatri. I'm from the Institute of Technology and my topic is vertex cover problem. I'm going to explain what is vertex cover problem with a small example. Before going to the main topic, I would like to explain what is graph. Graph is a connection of vertices and edges. What is vertices? Here is an example. In this diagram, 1, 2, 3, 4, 5, 6 and 7 are vertices in this graph. What is edges? These lines connecting the vertices are called edges. Simply, a graph can be defined as vertices and edges. In this graph, we have 7 vertices and some number of edges that are connecting the vertices. In the above graph, all the directions are undirected, so it is called as undirected graph. Coming to the vertex cover problem is totally related to the undirectional graph. It can be defined as undirected graph and to find minimum subset of vertices that covers all the edges. In this graph, we have to select the minimum number of vertices and that has to cover all the edges of the graph. In a given undirected graph, first of all, we have to find the degrees of all the vertices. Degrees means nothing but an adjacency of vertices. For example, vertex 1 is here. How many edges are connected here? 2 edges. So, the degree of 1 is 2. Likewise, we have to do it for 7 vertices. Degree of vertex 1 is 2. Degree of vertex 2 is 3. Degree of vertex 3 is 4. Degree of vertex 4 is 1. Degree of vertex 5 is 3. Degree of vertex 6 is 3. And degree of vertex 7 is 1. Coming to the procedure, remove the maximum degree vertex in the above graph and remove all its associated edges. First of all, find out the maximum degree vertex in this graph. What is the maximum degree vertex here? In our problem, maximum degree is 4 and the degree of vertex is 3. Simply, we have to remove all the connecting edges of 3 and the vertices 3. We can write the removed edges in a dotted graph. So finally, I have removed 4 edges which are connected to 3, 3 to 2, 3 to 5, 3 to 6 and 3 to 7. These are connected in a dotted graph. In the second step, after removing the vertex 3, we have some changes in our graph. Once again, we have to update the degrees. Now, we have to check the maximum number of degrees in the graph. The vertex 2, 3 and 5 has the maximum and the same degree 2. We can remove any one of the vertex in the graph. I am going to remove the fifth vertex and its associated edges. 5 to 6 and 5 to 2, both the edges are removed in this step. In previous step, we have removed 4 edges and in this step, we have removed 2 edges. In the final step, we have only 3 vertices, 1, 2 and 4 and the degree value is changed. The vertex 1 degree value is 2, other 2 and 4 vertices have the degree value is 1. So, we are selecting the vertex 1 and removing its edges. 1 to 4 and 1 to 2 edges removed. After removing all the edges in this graph, we have found the subset. In the first step, we have selected vertex 3 and removed all its edges. In the second step, we have selected 5 and removed all its edges. In the third step, we have found 1 vertex and removed all its edges. Finally, the subset is 3, 5 and 1. So, this is the solution which contains minimum subset of vertex that covers all the edges 3, 5 and 1. Thank you.